Okay, good morning. Okay, so we will go shortly on chapter 5. Actually, chapter 5 I dah bagi video. Okay, so I already gave last week, but tapi saya tak bagi at puzzle. Okay, so we just go through some important things from chapter 5, introduction and basic concept of thermodynamics. Okay, so what is thermodynamics? Okay, so it comes from a Greek term. Okay, term means heat and dynamis means power. Okay, so the science of energy. Okay, so thermodynamic is actually the science of energy. Okay, so thermodynamic, the science that deals with heat and work. Okay, so maksudnya ada dua benda yang ada dalam thermodynamic. So one is heat, okay, Abba, and also work, kerja. Okay, so and those properties of matter related to heat and work. Okay, so throughout the chapters, chapter 5 onwards, so kita akan banyak belajar berkenaan dengan Abba, dengan kerja, okay, heat and also work. Okay, so these are some history. So selalunya kita akan gunakan lah Kelvin, Rankine, Celsius. So it's all coming from the name of the scientists. Okay, so it's actually the first time the word thermodynamic is used is in 1849. Okay, so almost 200 years back. Okay, and textbook keluar 1859. Okay, so what thermodynamics law? Okay, so ada few laws, okay, berkaitan dengan thermodynamic. The first one that you need to understand is the conservation of energy. Okay, energy can change from one form to another form but cannot be created or destroyed. Okay, so whatever energy that is available in the universe is only changing form. Okay, so over time you cannot create or destroy it by yourself. Okay, you only can change from one form to another form. Okay, so first law of thermodynamic and second law of thermodynamic. Okay, first law of thermodynamic is saying the expression of the conservation of energy as a thermodynamic property. So meaning thermodynamic property is something yang kita boleh ukur. Okay, apa yang kita boleh ukur. Okay, so that is what we define. So I think kita ada buat lab. Okay, lab kita ada buat thermodynamic. Okay, first law of thermodynamic. So kita cuba ukur. Okay, it can be matter of time, it can be matter of height, or something that changes coming from the experiment. Okay, so that is what thermodynamic first law is saying. The second law of thermodynamic, so is saying that energy as quality as well as quantity, and actual process occur in direction of decreasing of quality. Okay, so meaning, so energy is not only measured in quantity. Maksudnya bukan sahaja dalam satu ukuran, tapi juga quality. So meaning our quality is the energy. Okay, so we have certain things that we use to calculate the quality of the energy. So berapa quality energy itu. Okay, and the process occur in decreasing of quality of energy. Okay, so if you can see here, apa maksud decreasing quality of energy? So again I show you the example. Okay, a cup of hot coffee, 70 degree, and environment dikeliling adalah 20 degree Celsius. Okay, so the temperature, kalau you tak buat apa-apa lah, so you just letak cup tu, then after some time 70 akan jadi 20. Okay, over time, so maybe 1 hour or 2 hour. So 70 degrees of hot coffee, dia after some time akan jadi 20 degrees. So that is what we say decreasing quality of energy. So maksudnya secara semula jadi hot coffee ni tak boleh dari 20 degrees jadi 70 degree unless you heat up. So letak dalam microwave ataupun you heat up, then you introduce heat, then it will become from 20 to 70. Tapi secara semula jadi 70 to 20. So bawah 20 dia takkan jadi, because the saturation point is 20 degrees. Unless your surrounding is 15 degrees, then dia akan turun jadi 15 degrees. Okay, so that is what we call as a direction of decreasing temperature. Okay, so there are two studies involved with thermodynamics. The first one is macroscopic. So macroscopic is also called as classic thermodynamic. Okay, makro maksudnya besar. Okay, micro maksudnya kecil. So you need to understand. So soalan ni biasa keluar lah. Okay, so makro maksudnya besar. So we call also as a classic thermodynamic. So meaning you don't need to focus so much on the particle. Maksudnya molekul dalam tu something yang kita tak boleh tengok dalam mata kasar. Okay, so that are the things related to microscopic approach. Microscopic approach, so maksudnya benda yang kecil. Okay, so we want to see the behavior of individual particle. So atom dalam tu, molekul dalam tu, so macam mana? So that are the two studies related to thermodynamics. Okay, so defining a system. Okay, if you want to do a study, so maksud you kena ada satu sistem dulu. Okay, sistem maksudnya benda yang you nak buat kajian. Okay, kawasan yang you nak buat kajian. So you cannot without defining the system. So then dia macam jadi how to say, it's like you are measuring the universe. So you kena cakap, okay, saya nak buat kajian ni antara kawasan ni ke kawasan ni. So you are defining the scope. So the scope tu adalah system. Okay, whatever you want to study. Okay, what you want to study? So you want to study a system of microwave. Maksudnya dalam microwave tu apa yang you nak measure. Okay, so that is what we call as a system. Okay, a region in space. Okay, only a particular region in the whole space. Okay, then we have a surrounding. Surrounding is region outside of the system. So maksudnya you ada kotak. So you ada satu kotak, I think ada gambar. Okay, boleh tengok dekat sini lah. Okay, so you have a system. Okay, system adalah yang warna kelabu ni. Okay, the grey area is what we call the system. The place where you want to do your investigation. And the surrounding adalah kawasan kat luar. Okay, so kawasan kat luar. Okay, and the interface between surrounding and also system. So you boleh tengok the dotted line. Okay, garis putus-putus. So that is the boundary. Boundary maksudnya sempadan. Okay, so that is the sempadan between the surrounding and also the system. Okay, and the boundary can be real. It can be real ataupun it can be imaginary. Okay, so that's what we can read here lah. So I just simplify. Okay, so the boundary is a real or imaginary surface that separates system. Okay, fungsi boundary untuk separate system dengan your surrounding. Okay, so you can see an example here. Okay, so ini yang something yang kita investigate dalam static fluid. Okay, so you have a container. Okay, so katakan yang ni adalah satu bekas. So surrounding, you ada atmospheric pressure. Okay, dekat surrounding. So dekat surrounding you can have a few properties. It can be a temperature, it can be a pressure. So that information that you can get from your surrounding. Then the boundary, so boleh tengok the garis putus-putus. And you have a system where you do your investigation. So that's why you can see there's a surface. Okay, surface number 1. Okay, and also you want to measure the pressure at the depth of each. Okay, so the formula is P2 equals to atmospheric pressure plus rho GH. Okay, so these are the things where you conduct your investigation. Okay, the region where you conduct your investigation, we call it as a system. Okay, so dalam chapter ni kita belajar few terms related to thermodynamics. Okay, so it's just an introduction. Okay, another term yang kita panggil as closed system. Okay, closed system ataupun kita panggil as control mesh. Okay, control mesh, a system that always contain the same matter. Okay, maksudnya you ada dalam piston ni ada gas. Okay, ada gas. So yang warna orange ke? Warna orange ni adalah apa tu? System. Okay, warna orange adalah system, then you have a boundary, then you have a surrounding. Surrounding dekat keliling ni. Okay. So in control system, closed system ataupun control mass, gas ni dia jumlah dia tak berubah. So katakan you ada 100 unit, sepanjang kajian you 100 unit tu tak akan berubah. Okay. So that is what we call as a control mass. No transfer of mass across its boundary can occur. Okay, so meaning you have a boundary, so dalam tu cuma ada 100 unit of gas. Okay, so no changes in the mass. Okay, so heat and work can cross the boundary. So because heat and work, so kalau piston ni gerak, is doing a work. So kalau ada temperature entering or leaving the system, so you have a heat transfer. Okay, then you also can have a isolated system. So isolated system maksudnya is a special type of closed system that does not interact in any way with the surrounding. No energy cross its boundary. So tadi saya cakap heat and also work can cross the boundary. So maksudnya it can come in or go out. Tapi dalam isolated system, so no energy cross. Maksudnya no work done or heat is transferred. Okay, so itu yang kita panggil as isolated system. So kalau dalam exam saya tanya apa itu isolated system, so you need to know how to define. So meaning no heat transfer ataupun no work done. Okay, from the system or coming from the system. Okay, so that is the closed system previously. So there's another system called as open system. Okay, open system ataupun control volume. Tadi apa yang kita control? Tadi kita control mass. Okay, maksudnya the unit tak berubah. So dekat sini kita control kawasan tu. Okay, meaning keluasan ataupun volume kita control. Okay, mass kita tak control. Okay, meaning mass is free to enter or leave the system. Okay, so one example yang selalu saya bagi, water heater. Okay, water heater dia dalam tu ada tank ataupun apa-apa dalam tu. So it's a control volume. So mass is entering, air masuk dari tank ataupun dari pipe, dia masuk. So inside the system, the water is heated, then leaving the system is the water. So volume dia tak berubah. Okay, volume heater tu ada yang kembang tak? Tak ada kan? Kalau air masuk dia tak kembang, dia volume dia sama. So yang masuk dan keluar adalah mass, which is the water. So that is what we call as a open system. Open system meaning, so mass can enter and leave the system, but the volume didn't change. Okay, so some similar lah dekat sini. So you have a setup here. So you have a imaginary boundary. Okay, yang garis putus-putus ni. Okay, so the water, ni ada gas lah. Okay, air is entering and leaving, so fuel is coming in. So dari luar, mass is entering and leaving the system, tapi volume dia ataupun volume apa? Lupa dah. Volume. Salah bahasa Melayu. Isi padu, sorry. Okay, so isi padu dia tak berubah. Okay, isi padu tak berubah. Okay, so you can see here also. So fuel is coming in, gas is going out, so air is coming in, work is done. Tapi yang ni dia tak berubah. Okay, that is what we call as a open system ataupun control volume. Selalunya pelajar akan confuse lah open system dengan closed system ni. Cuba remember this thing, control volume ataupun control mass. So then soalan ni pun soalan favourite lah. So explain the differences between closed system and open system. So you boleh, kalau suruh lukis gambar ataupun 5 marks, You can draw the picture lah, picture ataupun figure, then you can try to explain. Okay, so yang ni semua I dah explain lah. Okay, so properties of a system. Okay, so dalam sistem adalah satu kawasan yang kita nak buat kajian. So we want to conduct our study. So if you want to conduct a study, you akan deal dengan banyak parameter. So parameter ni adalah yang kita panggil as properties. Okay, a measurable or observable characteristic. Okay, so apa boleh tengok dekat sini. Okay, so property, one of the property macam pressure, volume, temperature, mass, viscosity, electrical resistance, thermal conductivity. So apa-apa yang ada the variable, so apa-apa yang boleh berubah, so that is what we call as a property, something yang kita nak ukur. Okay, so the properties can be divided into three. Okay, intensive. So intensive maksudnya independent to mass. Okay, mass selalunya kita ukur dalam unit apa? Mass, kg, kilogram. So apa-apa yang berkaitan yang tak berkaitan dengan kilogram ataupun berat, so that is what we call as a intensive. So macam pressure tak ada kaitan dengan berat. Elevation, ketinggian tak ada kaitan dengan berat. So all that are under the category of intensive. Extensive maksudnya dia dependent dengan mass. So apa-apa yang berkaitan dengan kilogram, macam total mass, total volume. So volume pun berkaitan dengan berat juga. Okay, so if the particular property is related to mass, then kita panggil as extensive. Then we have something called specific. Specific macam selalu kita tengok kan, specific weight, specific volume, so specific mass. So specific maksudnya extensive properties per unit mass. So tadi specific dia berkaitan dengan mass, and is also extensive, tapi per unit mass. So yang tadi itu tak perlu per, dia semua berkaitan. Yang ni per unit mass maksudnya per kilogram ataupun per mass. Yang ni actually okay, so yang ni formula dia. So V kecil sama dengan V besar, so volume per mass, per mass ataupun enthalpy. Apa-apa yang berkaitan yang per mass, kita panggil as specific. Okay, so that are all the properties. Okay, so boleh tengok dekat sini. So you have extensive property dekat atas. So inside a system you can have a lot of properties. So dekat sini ada 5 properties yang kita nak ukur. So 5 properties ni, so we can divide it into extensive and also intensive. Okay, so that is what about properties. Then kita juga ada state. State maksudnya keadaan. Okay, keadaan. So a set of properties that completely describe a condition of a system is known as a state. So maksudnya, so you boleh tengok gambar ni. So I explain dari gambar lah, senang. Okay, so you have properties. Dekat sini ada berapa properties? State 1 ada berapa properties? Ya? Siapa cakap 1? Siapa cakap 2? Siapa cakap 3? Oh, ramai cakap 3. So betul lah ada 3 property. Ada mass, ada temperature and also volume. Okay, ada 3 properties. Okay, so kalau properties ni you dah letak dalam satu tempat and is in equilibrium. Okay, equilibrium maksudnya dia boleh stand alone. So you tak tambah apa-apa ataupun you tak buang apa-apa, dia boleh stand alone. So that we call as state 1. Okay, so maksudnya is a combination of few properties and you are keeping it under one place. So that is first state. And then you have a second state. So dekat sini apa yang berubah dengan stage 1? Mass berubah tak? Mass tak berubah, still 2 kg. So temperature berubah tak? Tak berubah. Apa yang berubah? Volume dari 1.5 meter cube increase jadi 2.5 meter cube. So when you have this, so we call this as a state 2 ataupun second state. Okay, so apa state yang you mula. Okay, the state where you start we call also as a initial state. Okay, initial. So maksudnya state 1 adalah initial state. State 2 adalah the next state. Okay, atau so katakan your process tu cuma ada 2 state. So state 1 kita panggil as initial state. State 2 kita panggil as apa? So initial, last state ataupun final state. Katakan proses tu cuma ada 2 state. Kalau ada 3-4 state, yang final, yang paling ujung tu kita panggil as final state. Okay, so equilibrium. Okay, so that's another thing we call as a equilibrium. So equilibrium is the state of balance. Okay, so state of balance. Meaning state of balance maksudnya there are no unbalanced potential or driving force within the system. Meaning you tak bagi apa-apa force or anything, and the system can be balanced by itself. Okay, so that is what we call as a equilibrium. Okay, so, contoh dia macam saya selalu bagi, okay, so katakan you tuang air atas table ni. So after some time dia akan jadi tak bergerak. Okay, kalau you tuang dia akan gerak. After some time dia tak bergerak. So kalau dia tak bergerak maksudnya dia dah sampai equilibrium state. So dia akan bergerak bila? Kalau you tube dia akan bergerak ke satu lagi kawasan until it become equilibrium. Then dia akan stop. Okay, that is what we call as a equilibrium. Okay, similar lah, state of balance. Okay, so there are few equilibriums that we can see in thermodynamics. First adalah thermal equilibrium. Apa itu thermal? Thermal adalah berkaitan dengan temperature. Okay, so apa-apa yang berkaitan dengan temperature. So meaning thermal equilibrium maksudnya no temperature gradient. Maksudnya macam tadi 70 cup of coffee 70 degrees. So surrounding adalah 20 degree. So dia akan turun gradually over time. Then selepas dia sampai 20 degrees Celsius, dia dah sampai thermal equilibrium. Dia takkan jadi kurang dah. Dia dah jadi stable. Okay, so thermal equilibrium adalah berkaitan dengan temperature. Then we have a mechanical equilibrium. Okay, mechanical equilibrium maksudnya no pressure gradient. So mechanical berkaitan dengan pressure. Okay, so no pressure gradient maksudnya sama juga, sama macam temperature. So you have a pressure gradient. So maksudnya pressure tinggi ke pressure rendah. So automatically dari tinggi dia akan jadi ke rendah. So once it reach the pressure gradient yang sama, dia akan stop. So that's what we call as a mechanical equilibrium. Then we have a phase equilibrium. Macam tadi kita ada phase 1, phase 2, phase 3. Okay, so if your system has more than one phase, okay, lebih daripada satu fasa, dia kena ada satu phase equilibrium. Okay, mass of each phase is in equilibrium. Okay, so maksudnya after some time your phase become stable, and unless you introduce something inside, dia baru akan ubah fasa. Okay, so we have a term called phase equilibrium, and we have a chemical equilibrium. So chemical, so whatever things that, especially liquid lah. So liquid selalunya dalam tu ada chemical. So So chemical, so let's say I say minyak. Okay, we have oil. So we have oil. So dalam tu pun ada certain chemicals inside. Okay. So if the chemical is not reacting ataupun tak berubah, so meaning you already reach a chemical equilibrium. Okay, and no reactions occur. Maksudnya no new reactions occur unless you introduce something. Okay. Okay, quasi, that's a term called quasi equilibrium. Apa tu quasi? Okay, ada jawapan dekat sini dah. Quasi maksudnya almost. Okay. Okay, almost. So kalau quasi equilibrium maksudnya almost equilibrium. Maksudnya dia masih ada perubahan. Selalunya after some time, maybe when the gradient is big, so dia akan berubah secara drastik. Dia akan nak capai equilibrium. But once it already approach the equilibrium, dia ada perubahan tapi very slow until in quasi equilibrium state dia nampak macam dia tak ada perubahan, tapi actually dia ada perubahan yang sangat kecil. Okay, so that is what we call as a quasi equilibrium. Okay, a sufficiently slow process. Okay, sufficiently slow process allows the system to adjust internally, so the properties in one part of the system does not change any faster than another part. So meaning what is actually saying, it is sufficiently slow until you still can conduct some investigation. So dia tak berubah dengan banyak lah. Okay, macam gambar dekat piston ni. Okay, you have state 1 to state 2. So you apply a force, so it is compressing slowly. If the compression is low, we call it as a quasi equilibrium. Kalau high pressure between, so kalau low pressure selalunya dia quasi equilibrium. Tapi kalau you apply a force, the pressure is high and the compression is fast, then we call it as a non quasi equilibrium. Maksudnya it's still a fast movement, fast equilibrium state, tapi it's not a quasi ataupun a slow compression. Okay, in most of the process that we will study, one thermodynamic property is L constant. Some of these properties are term ni pun kita selalunya akan dengar. Okay, ISO tu apa? Isotonic biasa dengar kan, isotonic. ISO tu apa? ISO tu maksudnya constant, maksudnya tak berubah. Isotonic tak tahu lah apa yang ISO dalam tu. Tapi dalam thermodynamics there is a term called ISO. ISO means constant. Okay, so isochloric selalunya berkaitan dengan volume. Okay, so isochloric, kalau you dalam soalan exam dia cakap isochloric, so you need to understand that it is saying that the volume is constant. Okay, so isochloric. Then you have isobaric. Okay, baric selalunya macam barometer adalah berkaitan dengan pressure. So isobaric maksudnya constant pressure. Okay, so that's the term. Then yang ni dia advance sikit lah sebab dia berkaitan dengan temperature. So that's the term called enthalpy and also entropy. Okay, the quality of the heat transfer, the quality of the energy. Okay, so enthalpy dekat sini tak ada ISO, dia tulis IS je. Okay, is enthalpic maksudnya a constant enthalpy. Then you have yang enthalpy selalunya kita tulis as H, and S adalah entropy. So untuk constant entropy kita panggil as isentropic. Isentropic. Tapi term ni selalunya tak keluar lah. Yang selalu keluar dua ni. Okey. Dengan yang ni, isothermal. Isothermal maksudnya constant temperature. Okay, so that are some of the terms that we L constant. Selalunya kalau dia ada 3, 4 ataupun 4 benda yang you nak cari, dia payah. So is always one property kita jadikan dia constant. So memudahkan kita untuk cari the other two properties. Okay, take 5. Okay, 8:45, 8:50 will restart. Ada few lagi slide. Okay, for this week, hari ni kita nak buat sedikit discussion on this. Actually, yang ni bukan discussion dah, ini dah jadi lecture dah untuk chapter 5. Sebab kita bagi add puzzle kan, so it's okay. So still ada dalam 5 or 6 more slide. Okay, so we will discuss this. Then later saya akan sambung dengan chapter 6. So chapter 6 actually ada dua part 1 and part 2. So part 1 kita akan cover nanti selepas habis chapter 5. So I will continue with chapter 6 part 1. Tapi part 1 tu dia ada 29 slide. So I don't want to go too fast. I just want to make you understand. So kalau kita tak habis hari ni, so maybe kita akan buat class on Friday morning. Okay, untuk finish up the remaining. Yang part 2 saya akan bagi add puzzle. Okay, so just additional. Okay, so we will finish up these slides. Okay, so the next one is the state postulate. Okay, a state postulate is a number of properties. So tadi kita tengok ada properties macam temperature, volume. Okay, so this is a specific volume. Okay, so the number of properties required to fix a state. So state is something that is not apa? The state is of a compressible system is completely specified by two or more independent intensive properties. So meaning, so a state, when you have a state in a system, you need to have a few things in order to tie it up. So maksudnya untuk jadikan dia satu state, dia perlukan beberapa property dalam tu untuk jadikan dia satu state. So that is what it is actually saying. Macam dalam gambar ni, so nitrogen, okay, a system consists of nitrogen. So you need to have a temperature and also specific volume to make it a state. So that is what we call as a state postulate, the number of properties required. So dalam case ni, dia perlukan dua state postulate ataupun two properties to make it a state. Okay, so a simple compressible system, if a system involves no electrical, magnetic, gravitational motion or surface effects, so we call it as a simple compressible system. So the only energy transfer by work is the volume change. So yang ni sebab dia compress kan. So waktu you compress, volume akan berubah. So but it is not really related dengan electrical, so tak ada electrical, magnetical, gravitational motion ataupun any surface tension effect. So yang itu maksudnya a simple compressible system. Okay, meaning it's a very independent system. Okay, part and process. Okay, so boleh tengok dekat sini. So another term, a part or a process. So perkataan ni selalunya kita dengar lah proses. Apa itu proses? Okay, so a change a system undergoes from one equilibrium state to another is known as a process. Maksudnya boleh tengok gambar ni. So this is your initial state. Okay, dekat state ni, so it's already reached equilibrium. So maksudnya you don't do anything, so it's already stable. So we consider it as a state 1. Then you introduce something, then from state 1 dia jadi state 2. Okay, state 1 to state 2, yang ni adalah satu proses. Okay, process of changing from state 1 to state 2. So that is what we call as a process. And in between So apa yang berlaku, yang ni kita panggil as path. Path maksudnya perjalanan lah. Okay, from year to year. So meaning here you have two state, one process, one path. Okay. So boleh tengok lah. So this is actually from here state 1 to state 2. So meaning you're compressing this piston. So it's moving from state 1 to state 2. So perjalanan ni kita panggil as path. So this is state 1, this is state 2. Okay. So this whole thing we call it as a process. Okay. Then another term yang kita panggil as a cycle. Selalunya kita panggil as a cycle, ataupun dalam bahasa Melayu kita panggil sebagai kitaran. Okay, kitaran. Okay, so kita tahu state like here kita ada dua state, state 1 to state 2. So a cycle, a system is said to have undergone a cycle if it is returned to its original state at the end of the process. Maksudnya dia start dekat sini, dia pergi ke state 2, then dari state 2 dia balik ke state 1. Meaning it's already complete a cycle. So katakan you ada empat state. State 1, so dia pergi ke state 1, ke state 2, state 2 ke state 3, state 3 ke state 4, then dari state 4 balik ke state 1. So meaning it's already complete one cycle. So not necessarily kena ada dua cycle je. Okay. So if the initial and the final state are the same, so meaning it completed one cycle. Okay. So in a process you can have a few cycle. Dia boleh buat beberapa kitaran lah. Okay, so you can have a few cycle. So cycle is another term that we can use in a thermodynamic. Okay, then we have a temperature. Okay, what is temperature? Okay, if two blocks, one warmer than the other, are brought into contact and isolated from the surrounding, they will interact thermally with changes in observable property, and all changes in observable properties is the two blocks are in thermal equilibrium. So temperature is a physical property that determines whether the two objects are in thermal equilibrium. Okay, so dari sini kita tahulah. So temperature, so you ada dua block, so ataupun dua physical blocks ataupun dua benda lah. Yang satu panas, satu lagi sejuk. So kalau you bagi dia sentuh, after some time yang panas, the temperature akan transfer. The heat transfer will happen from the warmer one to the less warmer. So macam tadi 70 degree dengan 20 degree, kalau dia bersentuh 70 degree dia akan transfer the heat, apa tu akan dipindahkan ke yang kurang panas. Then after some time dia akan jadi equilibrium, ataupun kita panggil as thermal equilibrium. So the temperature is a physical property that determines the two objects are in thermal equilibrium. Okay, so boleh tengok dekat sini apa yang saya explain tadi. Okay, so before that, so there is another thermodynamic law yang kita panggil as zero thermodynamic law. Okay, if two bodies are in thermal equilibrium with the third body, they are also in thermal equilibrium with each other. Boleh tengok dekat sini lah. So you have iron which is under 50 degrees dengan copper 20 degree. So after some time apa akan jadi? So kalau you letak besi 150 degree dengan copper, so after some time, so katakan you bagi 1 jam ataupun maybe setengah jam, so what will happen? So iron temperature tinggi ke rendah? So memang nampak dekat sini kan, so dia akan rendah because the copper is kurang. So copper ni dia akan jadi tinggi. So after some time, dua-dua akan jadi temperature yang sama. So which can be 60 or 50 or 70, not necessarily 60 lah. So whatever things. So maybe over time, if the surrounding, so yani maybe after 30 minutes. So if the surrounding is 20 degrees, maybe yani dia akan jadi after some time jadi 50 degrees, 40 degrees until dia jadi 20 degree. Selepas 20 degree, dia akan kurang ke tak? Dia tak akan kurang. Kenapa? Sebab dia dah sampai thermal equilibrium with the surrounding. Unless your surrounding is 10 degrees Celsius, so dia akan kurang jadi 10 degrees, kemudian dia akan stop. Okay, so that is what we call as a thermal equilibrium. Okay, so temperature scales. So apa yang kita boleh gunakan untuk mengukur temperature? Okay, kita ada Kelvin scale, kita ada Rankine scale. Selalunya kita hanya akan gunakan Celsius, sebab Celsius ni dah digunakan dalam banyak benda. So kita pun dah faham dah dari kecil. Kita tengok thermometer, dia start dari 0 sampai 100. Okay, so it's easier for you to remember. Tapi actually there are 3 other scales that can be used. The first one is Kelvin. So boleh tengoklah formula dekat sini, so how you can change. So you have a Kelvin scale. Dia start dari 0 sampai berapa? 373.15. Yang point-point ni yang kita tak boleh remember kan. So it's easier for us to use Celsius. Start dari 0 sampai 100. Yang ni Kelvin, dia start dari 273.15 sampai 373.15. Nak sebut pun susah. Okay, nak ingat pun susah. Okay, then we have a Rankine scale. Yang ni memang kita pun tak guna lah. So kita pun tak gunakan. Tapi adalah scale ni. So dia start dari 491.67 sampai 671.67. So tak tahulah apa logik dia. Dia create this scale. Nak ingat pun susah. Then we have a Fahrenheit. Okay, yang ni pun kita biasa guna. Okay, dia start dari 32 sampai 212. Okay, so you have this Fahrenheit. So ini adalah formula-formula yang you boleh gunakan dalam conversion. Okay, jangan risau dalam exam I tak suruh you convert. So dari Celsius ke Fahrenheit, tapi you kena tahulah. Okay, ada benda ni. Okay, these are the things that available. Okay, mostly dia ada perubahan dari segi SI unit. SI unit selalunya kita gunakan Kelvin. Kita selalunya gunakan juga Celsius. Tapi Rankine dia more kepada British ataupun English based system. Awal-awal I think first chapter kita ada belajar kan, ada apa pound, ada apa lagi, so ada few other properties yang berkaitan dengan British unit. So yang ni Rankine pun dia berkaitan dengan British unit. Okay, Rankine, Fahrenheit semua berkaitan dengan British unit. Okay, so end of chapter 5. So these are something related dengan chapter 5. So ada soalan? Any question? Ada soalan ke apa-apa? Okay, kalau tak ada, so we will proceed to chapter 6. So I will try to cover as much as possible. Okay, chapter 6 part 1. Okay, dalam chapter 6 energy, kita akan belajar pasal energy transfer and general energy analysis. Okay, so few chapters kita akan cuba belajar on the energy. Okay, so introduction. Okay, so I think before we start, okay, can you off? Boleh off tak? Off.